Bivariate statistics. In this video we will be taking a look at bivariate statistics, which is a very important topic in IB Maths as it appears in virtually every IB Maths exam. Bivariate statistics looks to see if there is a trend between two sets of data, if there is a relationship between one set of data and the other. In this example, we have some company selling ice creams, and we want to see if there is any relationship between the temperature on the day and the number of ice creams sold on that day. This is a perfectly typical IB Maths exam. We would expect there to be some relationship between the temperature and the number of ice creams sold. We would expect not very many ice creams to be sold on cooler days. You're more likely to go and buy a cup of tea or a cup of coffee on a cool day. Whereas in a hot day, we would expect more ice creams to be sold. So in this example, I've drawn out our data. We've got the temperature along the horizontal axis, T, and we have the number of ice creams sold on the vertical axis, N. And we've plotted the points for the average temperature against the number of ice creams sold on that particular day. And what we want to see is if there is a relationship between the number of ice creams sold and the temperature on that day. And we want to draw a line of best fit. And what we mean by a line of best fit, or linear regression, and all linear regression means is a straight line of best fit. And in this case, the line of best fit might look like the following. So that's what our line of best fit might look like. You want it as close as possible to as many of the dots and going through as many as possible. Now with this linear regression line, it's a straight line, so we'll have a formula, and we can use the linear regression line to look at data that does not appear in our two sets. So we might want to find the number of ice creams sold when the temperature is 17 degrees Celsius. 17 degrees Celsius does not appear as one of our temperatures, but we can use the linear regression line to find an estimate for the number of ice creams that would be sold if that was the temperature. But first, we must find the equation of the line of best fit, and we do this using our GDC. Put into the calculator T, which represents the average temperature, is on the x-axis, and the number of ice creams, N, is on our y-axis. And so with the TI Inspire, we can go to Menu, Statistics, Stat Calculations, and we want linear regression. There's two types of linear regression. We use mx plus b because that is the equation of our straight line. So we click on that. And we have our x and y list. Our x list is t, so we type in t. Our y list is n. We can leave everything else the same, so OK. And here we get all our four important values that we want. M is 1.571, B is 17.142, R squared is 0.909, and R is 0.953. So let's write those values down. M is equal to 1.571. B is equal to 17.14. R squared is equal to 0.909. And R is equal to 0.953. Using those values for M and B, we're able to write an equation for the line of best fit. So N, the number of ice creams, is equal to 1.57 to three significant figures T plus 17.1. We could then use that equation to find the number of ice creams sold for any temperature. So a typical question might be, going back, find N when T is equal to 17. We can just substitute into the equation, so we will get N is equal to 1.57 times 17 plus 17.1. So N is equal to 43.8. So N is equal to 44 to the nearest whole number. So at a temperature of 17 degrees, we would expect 44 ice creams to be sold. Now, what does the R value tell us? Well, the R value tells us the strength of the relationship between our two variables. So in this case, how strong is the relationship between the temperature and the number of ice creams sold? On the right hand side is a series of 9 diagrams showing you strong, moderate and weak positive, strong, moderate and weak negative, and no relationships whatsoever. The closer the R value is to 1, the stronger the relationship between the two variables is. A perfect relationship would have an R value of either +1 if the relationship was positive and -1 if the relationship was a negative relationship. The following table shows us how to interpret the R value. If the R value is between 0 and 0.25, it's very weak, the relationship. If the R value is between 0.25 and 0.5, it is a weak relationship. If the R value is between 0.5 and 0.75, you have a moderate relationship. And if the relationship is between 0.75 and 1, it is a strong relationship. So in this case, our R value is 0.957, so we would class this as a strong relationship between the two variables. So we can quite confidently say there is a strong relationship between the temperature and the number of ice creams sold by this company. This is a typical IB question. The following table below shows the marks scored by 7 students on 2 different maths tests. Test 1 is your X variable, test 2 is your Y variable. Let L1 be the regression line of X on Y. The equation of the line L1 can be written in the form X equals AY plus B. Find the value of A and B. This can be done on your GDC. And putting your 2 lists into the spreadsheet. One called X, one called Y. Then click on an empty cell, menu, statistics, Stat calculations, linear regression. Now be very careful, because in question 1, you want the regression line of x on y. So that means your x coordinates is your y list, and your y coordinates are your x list. So make sure you put the right lists in the right column. Okay, and there you go. So, regression line mx plus b, where m is 1.29 and b is minus 10.3. So now let's answer the question. We can write our regression line y equals mx plus b. So y equals 1.29 x minus 10.37. Therefore, A is equal to 1.29 and B is equal to minus 10.37. So, 1b. Let L2 be the regression line y on x. The lines L1 and L2 pass through the same point with coordinates PQ. Find the values of P and the value of Q. Again, you can use your GDC to answer part B. Data is already in there. Go to the right, find a empty cell, and in order to find the common point to both, the only point that is common to both regression lines is mean x and mean y. So you can use your GDC to find mean x and mean y. So menu, data, list maths, mean, and just type in x, enter, and so the mean of x is 201 divided by 7. Now do the same for y. So menu, data, list maths, you want the mean of y, enter, so the mean of y is 212 divided by 7. So part B. P is equal to 201 divided by 7, which is equal to 28.7, and Q is equal to 212 divided by 7, which is equal to 30.3. Part C. Jennifer was absent for the first test but scored 29 marks on the second. Use an appropriate regression line to find the score she should have got on the first test. We can use the equation y equals 1.29x minus 10.37. Knowing that x is equal to 29. Therefore, y is equal to 1.29 times 29 minus 10.37. Therefore, y is equal to 27.1 to 3 significant figures.